Right, in this question we're being asked to work out a pH, but we have to work out a pKa to start with. We're told that at a pH of 6.5 that we have an aqueous solution of hypochlorous acid is 7.6% dissociated, and we need to calculate the pKa and hence find the pH. So the first thing we need to find out is the pKa. So if we now if you forget how to do the Ka expression, remember you can just write out the equation for the dissociation, which is going to be Cl minus plus H3O plus, and then you can turn that into a Ka expression, which is just going to be products of a reactants, ignoring water of course, and that's HCl. And we're given some interesting information here. We said it's 7.6% dissociated, so we can just treat that as a ratio, this percentage. So that's 7.6%, so if there's 7.6% of this, and obviously 100% we started with, 100 minus 7.6 is going to be 92.4, so I don't know why I put 7.66 there, so just change that. And that number there is 92.4, and the pH of 6.5 because it's the hydrogen ion concentration to go there, so we can do a calculation there to work out the Ka, and that's going to end up being sorry, just a minute to do that, 2.6 times 10 to the negative 8, and we can turn that into a pKa just by doing the minus log. So log 2.6 exponent negative 8, and we change the negative to a positive, and that's 7.58. So we have the Ka and hence the pKa for the acid there, and that's the first part there. Now just writing out the equation for this, because one thing that is easy to overlook is that this is actually the base. It's not HClO, it's ClO minus, so we're actually interested in the weak base formula, which is just Kb equals OH minus squared over the concentration of the base we're interested in. Now Kb, obviously we just calculate by going 1 times 10 to the negative 14 divided by the Ka, which we worked out earlier, which was 2.6 times 10 to the negative 8. So that's where that number there came from. Now the concentration of the base, we're told that it's 40 milligrams, so that's 40 times 10 to the negative 3, because milli is 1,000th, and we divide that by 143, and that will give us the number of moles, but because there's a 2 here, we have to multiply it by 2, because when this dissolves it gives twice as many chlorate ions, and that will give us something in the region of 5.59 times 10 to the negative 4 moles, and we're assuming it's in 1 litre at the moment because it's grams per litre. And if we then place that into the equation here, we should be able to work out the amount of hydroxide ions concentration, and then we just need to turn that into a pH, and we should end up with 9.16. So a little bit of a twist there with having to do the times by 2, and remembering to take note that this is a base we're working out, not an acid. Okay, and that's that question.